Welcome. This is Model Builder, Creating a New Adaptation, Intro to the ASW, a quick clips video resource for SDSFIE training. This training resource is designed for all users who want to learn about using the Model Builder tool to create an adaptation of an existing vector model in the SDSFIE portal registry. The prerequisites for this training are the first two in the series of SDSFIE quick clips on Model Builder, the model development process and available options video, and the need to build an adaptation, profiles, changes, and extensions video. The overall goal for our training resources is that all SDSFIE users understand the purpose, structure, and parts of the SDSFIE family of standards or standards framework and how to implement those standards. The specific objectives for this presentation are that the audience gains an understanding of the following: how to access the Model Builder tool and download the Adaptation Submission Workbooks, or ASWs, what the purpose of the ASW is and how that relates to its structure, and how to populate an ASW. This is the 6-step process for developing an SDSFIE V-compliant model using the Portal Model Builder tool, displayed with the quick clips videos that demonstrate those steps. The previous video demonstrated steps 1 and 2, defining requirements for the target adaptation and recording elemental level profile, extend, and change decisions relative to the parent model. The next steps, 3, 4, and 5, will be covered in this and the next video. In this video, we will go to the SDSFIE portal, start the Model Builder tool, download the ASW, and examine its different worksheets and populate them relative to the change decisions. In the next video, we will import the ASW to Model Builder, run validation, identify and fix errors in the ASW, and create the new model in the portal registry. There are several videos that address the browse and generate functions of Model Viewer used in Step 6. This is a condensed view of the list of tabbed worksheets contained in the 5.0 ASW template. As we will see in a moment in more detail, the template is designed to provide, in a highly structured manner, all of the forms needed to specify the parent model and output model properties, and, for each of the different element types, specify the profile, extend, and change actions to be performed on the parent to build the adaptation. While there are 16 different tabs that can be populated, only populating the Project tab and one other tab is required to create a new model. For the demo, we will populate 8 of the tabs in a pre-5.0 ASW, noting that the pre-5.0 ASW has 5 fewer tabs without the attribute group and mission dataset 5.0 tabs. We will now demonstrate how to take Step 3 and Step 4 in the model development process by visiting the Model Builder tool, downloading the pre-5.0 and 5.0 ASW templates, examining details of the template structure, and populating the pre-5.0 template with those profile, extend, and change actions to produce the component adaptation. At the portal homepage, sdsfie.mil, I will log into the system with my user credentials. Once logged in, the available portal tools are presented. Clicking on the Model Builder card opens the tool in a new browser tab. Here, the user is presented with 3 options: downloading an ASW template in the newest version for 5.0 models, downloading a pre-5.0 template, or moving on to the Validate and Create steps. I will download a copy of both. Let's first take a look at the 5.0 template to see the expanded set of element types available with the 5.0 model. After opening the downloaded Excel workbook template from my Downloads folder, let's first look at the instruction sheet. Along with a description of the ASW's purpose, which we already know, and a list of tabs which we have just previewed, there is a description and any special instructions needed for each. Below that, we see a key to the different cell and font colors used for column headings as they appear throughout the workbook tabs. Note that the top 3 types indicate columns that the user may populate, with the bottom type for model reviewers. Among the top 3, the first is required, a tan color font with a single asterisk, which means that if you need to populate records in that sheet, then you need to populate values in that column. The second heading type is required if applicable, which is also tan but has 2 asterisks, and the third is optional. From the bottom of the Excel workbook interface, we will next go to the project sheet. Here you can see the approach for denoting required and optional columns is used here for the project-level fields that define the parent and target models. Note that there are 6 required fields, and that hovering over each accesses notes about how to populate the field. The logical order for creating an adaptation is Profile, Extend, and then Change. So, using the tab arrows at the lower left, we will go to the Profile sheet. Looking at the columns, we see that all are either required, like the model element type and profile rationale, or required if applicable, like the entity model name and attribute model name. If, for example, I need to profile the wildland fire entity, then I pick the entity item from the model element type drop-down pick list. In this case, populating the entity model name is required, as stated in the note. With most every action, I will need to provide a rationale or justification for the action taken on the parent model. For profiles, I need to populate the profile rationale. Next, let's look at an attribute extension. As explained in the preceding video, only attributes that are not present in the parent model can be added to the adaptation, those that differ in concept, the definition property, as well as model name and alias name. If I need to add an attribute that already exists in the parent model, then I use the Entity Attribute Extension sheet. From the column headings, you can quickly see that there are only 3 fields for which population is required: Entity Model Name, Attribute Model Name, and a Justification field off to the far right. First, you specify the entity model name to indicate to which entity the new attribute will be attached, and then the attribute model name. There are, of course, many other sheets to explore in this 5.0 ASW, but they use the same format that has just been introduced and all follow the element rules specified in the SVIG. So we will now move towards the pre-5.0 ASW to examine how an ASW is fully populated for the element level requirements established in steps 1 and 2 of the model development process. Recall that in step 1 of the model development process, we defined the required elements for the new model, and in step 2, we translated those requirements to profile, extend, and change actions to be taken on the parent 4.0.5 Gold Core Agenda model. Prior to considering populating an ASW, let's do a quick refresh on the element level requirements for the 4.0.5 component adaptation for the transportation domain. For entities, only 3 of the 259 found in the parent model are maintained in the adaptation. The rest are profiled. The sign inventory data entity is added, making 4 total in the adaptation, and the alias of the road centerline entity is changed. For those 4 entities, all but installation are placed within the transportation feature dataset. For attributes, relative to the parent model, all are retained for the 3 maintained entities, except for the RPNID attribute of the sign entity that is profiled. Also to the sign entity, an instance of the existing operational status attribute is extended, and the sign text attribute is changed by adding a value for the note property. For enumerants, all of the activity is in the sign primary type enumeration. The school enumerant is profiled, and the advertisement enumerant is extended. Now that we understand the actions, let's move to the pre-5.0 ASW for this component adaptation about transportation. We will start here in the project sheet. The first thing that you might notice is that some of the tabs have green highlights. Of the 10 sheets in the pre-5.0 ASW that may be populated, the 8 that have already been populated for this adaptation are highlighted. On this project sheet, note that the basis and parent adaptation name are both filled out with the same value, STSFIE 4.0.5 Gold Core Agendum. For individual ASWs that serve as links in a daisy chain of files and corresponding models, an approach used for some component adaptations and upgrades, the parent adaptation would differ from the original basis model. Let's look at how the actions on the parent model are expressed in the ASW. Following our logical order of profile, extend, and then change, we first go to the profiles sheet. Starting in row 4, we see that all 259 entities present in the parent model are entered here. This includes the 3 that are going to be maintained in the adaptation: installation, road centerline, and sign. Note that these 3 entries have a pound sign in the leftmost column. The note for that column heading states that rows that have a pound sign are completely ignored. Thus, the profile actions will not be executed on these 3 entities. They were included here for accounting purposes, in this case to include all 259 entities. The other 2 profiles are at the top of the sheet, one for the RPNID attribute from the sign entity, and the other for the school enumerant from the sign primary type enumeration. The model element type being profiled in each row is specified in column B. The different types are selected from a pre-populated drop-down list. Note that there is an error in row 3 for the school enumerant. The type listed is enumeration. We can correct that error by changing the type to enumerant, like so. Moving on to extensions to the parent model, we will start with entities. Here we see the single entry sign inventory data that is being added to the profiled parent model. We can see that it is a non-spatial entity, and so it has no specified geometry types. There is an error in this entry as well. Can you spot it? In our review of the requirements, remember that all of the entities except installation were to be placed within a new functional dataset named transportation, so we will fix that now and save the file. Next in the element hierarchy is attributes. Remember that in the portal registry, attributes are stored at the model level with a limited set of fixed properties, and then are applied to entities as entity attributes with flexible properties. In reviewing the attribute requirements, we only considered the sign entity, and there was one extension, an operational status attribute. The question that we must ask before extending an attribute is, does it already exist at the model level? In fact, the operational status attribute does exist in the parent model and is attached to 54 entities. So we don't need to extend it at the model level, but rather just as an entity attribute in that other sheet. We can either delete this row or comment it out like so. If we consider the sign inventory data entity, there are actually 11 other attributes to be attached. Again, these were not specified in the requirements review. Here again, we need to check to see which ones already exist in the parent model, and it turns out that 3 do: height UOM, SDSID, and width UOM. So they have been commented out as well. Next is the entity attribute extensions. Here, all 13 of the entries from the attribute sheet, those commented out or not, are present to attach the model level attributes to entities. There is one typo here that is intentionally introduced. In row 7, the SDSID attribute is spelled with a lowercase I. This is a good example of an error that Model Builder will identify and report, and we will then fix. For enumeration and enumerant extensions, there is only one enumerant to add to an enumeration that exists in the parent model. Per the requirements, we are adding an advertisement enumerant to sign primary type. You probably already noticed the typo in the enumeration model name. This is another typical error that will give us experience in the iterative model builder process. The last extension type is functional dataset. As you can see, functional datasets contain only 2 properties. We assigned the new sign inventory type entity to this new transportation functional dataset already. For the existing entities, we will do those assignments in the Changes sheet, our last stop in this ASW. Here in the Changes sheet, the first two entries are those two functional dataset assignments. Next are the two changes specified in the requirements review. Note that populating records for the previous value column is optional. The word blank in brackets is simply used to denote cases for which the particular property, specified in the column to change field, holds no value in the parent model. Finally, let's look at an example of adding an entire entry from scratch, adding a note to the sign primary type enumeration. At minimum, we need to enter values for all required columns. First, we will set the model element type to enumeration. Next, we will enter sign primary type as the enumeration model name. As seen, the column to change value, enumeration to note, is selected from a long list of element properties presented in hierarchical order. As with the other entries, we can add the blank indicator as the previous value, and also copy down the justification here named change rationale. Once saved, the file is now ready to be uploaded in Model Builder, which is the topic of the last video in this series. This concludes the Model Builder, Creating a New Adaptation, Intro to the ASW presentation. The next video in this series on Model Builder is about using the ASW we just reviewed and edited. If you want a more comprehensive training video on Model Builder, see the first background resource listed here. All these and videos on other in-depth topics and background content are available from the Training Resources page at the URL shown. Thank you for your interest in STSFIE.